hand it around, so if you can discreetly pass it around the tables so you can sign up. Sign up on the one on the left. This is for this week's speaker. This one's for next week. Just trying to conserve paper a little bit, all right? The other thing to remember if you're signed up for that class is you've got to post some follow-up discussion posts to Canvas. So Lauren and John, I would like to say they volunteered to be this week's, but I forced them to. So they are this week's discussion leaders. So remember, they will post their comments by Friday. And so if you're not a discussion leader, keep an eye out for their post, and then you can follow up and we can have a little discussion go on based on Scott's presentation in the paper that you read. All right, so more generally, welcome to the spring seminar series, which is a collaboration between Forest and Rangeland Stewardship Department and Ecosystem Science and Sustainability. And then we kind of rope in the GDPE seminar series as well. So keep an eye out for those because they're the same day and same time as ours. And we do that to try to minimize the plethora of seminars that are going around so we can hopefully all focus on similar ones and have more discussions based around those topics. So keep an eye out for that. Katie will be sending out announcements both for our own seminar series and GDPE. So we'll try to keep you up to date on what's coming up each week. All right? I think that's all I have to say. So I'm going to hand it over to Shri now.
Thanks, Troy. Good afternoon, everyone. And I would also like you to welcome you to the spring seminar series. I'm Srijana Baral. I'm an assistant professor in the Department of Forest and Rangeland Stewardship. It's a great pleasure for me to introduce Dr. Scott Markwith. He is our first speaker for the spring seminar series. Scott is a professor in the Department of Geosciences at Florida Atlantic University. He completed his MS and PhD in geography from the University of Georgia. He is an ecological biogeographer who examines population and community dynamics of flora and fauna under the influence of natural and anthropogenic disturbances, and also focuses on applications that inform resource management, conservation, and ecological restoration. I'm excited about Scott's talk and hope you are too. So please join me in welcoming Dr. Markwith.
Thank you all. I'm really happy to be here, excited to be here. I'm glad I can be part of your classes. It sounds like multiple seminar classes going on concurrently, and I'm glad that I can be here and be your first speaker for the spring semester. So let me get started here then. This talk, of course, my name is attached to it, but I want to recognize somebody else who is here today. And that's my former PhD student who is a postdoc here in Forest and Rangeland Stewardship, and that's Asa Paudel. She's sitting in the back, waving. She came to work with me from Nepal, and I hired her on for a joint fire science grant. And so the work that I talk about in terms of the field work at the beginning will be from that grant that she worked on. She also worked with me to flesh out the rest of her dissertation. I'll talk about more of her dissertation research. So, and collaborated then on the last paper that I'll talk about too, which you all read for the class. So, Asa, when you're clapping for me at the beginning, at the end, if I've impressed you, you can clap again. If not, you can laugh. But if you're clapping, you're also clapping for her. I just wanted to recognize that she was instrumental in all of this work also, and really the reason that I'm here, actually. So to get started, kind of the entry into how I'm going to talk about my research is a little bit to talk about how we see the past and future, how we think about it and how we speak about it. Most people on the planet, they talk about time and space, they conflate time and space. And we talk about, the past being in a space relationship to us and the future also. So in most languages, then when we talk about the future, we're talking about the future is like in front of us. We're moving forward like towards the future, right? You can kind of think of that in terms of how we conceptually think about, the future and science fiction and all this advancement and everything. And so there's always sort of this looking forward and moving forward sort of thing. And when we think about past events, we're usually thinking about, okay, we've passed the past. The past is behind us, right? And you can think of this also in ways normal things that we say from day to day that we don't normally really think about, right? So, you might say, oh, we're coming to the end of the year, like we're approaching it, we're coming to it, right? Or, if you're talking about the past, somebody who had a difficult childhood, you might say, he's left his difficult childhood behind. It's behind him. The past is behind him, right? And then you can, stop looking in the rearview mirror at the past, and you need to move forward. So these types of things, like regular phrases, like things you just might say offhand to somebody, it reveals this spatial relationship that you have and think about in your language, and that shapes your mind and how you think about the past and the future. There is a group of people, there is a language family that thinks about this differently. The Aymara language, and they are in the border region between Bolivia, Peru, and Chile. The word for front is really the same word for past. So when they talk about the past, they're not talking about it being behind them, talking about it being in front of them. And when they talk about the future, they're talking about the future. It's the same word as being behind you. And so the past, the reason for them it's in front of them is because they saw the past, they experienced it. So it's in front of their face, it's in front of your eyes. And the future, on the other hand, it's unknown. It's unobservable, right? And so for them, it's behind you, it's behind your head, it's out of your view, it's out of your eyesight, right? And so it's a different concept of past and future. And that's why I gave my talk, the title that I did, that both the past and the future, and when it comes to management, forest management, and fuels management, in a way, if we combine these different views of space and time, they're both behind us. And you'll see how I bring that concept a little bit through this talk as we move forward. So this is not based on my research in terms of the Aymara. It's from Nunez and Sweetser from 2006, and they've done extensive work on their language family. So if you're an Aymara, if you speak Aymara language, then how do you go to the future? Well, you go back to the future, right? This is the funniest part of the talk. But I just wanted to throw that in there. But they go back to the future. So we do have some blind spots then, in the past and some blind spots in the future. It might be easier for us to picture, sort of, even though we can't observe the future, but what some of those blind spots might be. We think that forest management, we're facing these big challenges with climate change. We see on the news every year about the fires all over the Western United States. Especially I'd be talking about fires in the Sierra Nevada region in California. Those massive fires that you see out there that are huge and destructive, but also in other regions of the Western US. So we know that things are changing, obviously. But of course, we can't really see it. It hasn't happened, right? So from a Aymara perspective, it's not, in front of our face, but we still know it's coming. Well, how can we know something about that? Of course, we have the technology and the ability to produce different types of models, simulation models, process models, all kinds of computational models. But we're also aware enough to know, as our friend George Box said famously, all models are wrong, but some are useful, right? So keep that in mind. We can represent the future, but ultimately, we can't know exactly. So management strategies, though, they can draw from the past, right? And we do that all the time. We know things about the past. We know that there have been fires that have been occurring, over millennia. We can look at, different ways, proxies, to be able to get information about that. We know that native peoples used fire, and so we can draw from that history for management strategies. But, how complete is that understanding of the past? There are some problems with only relying on that. What about the written history and the systematic science? So in this country, in North America as a whole, really, written history that, goes back, okay, maybe the Spanish in the 1500s or something like that, for the English written language, not as long. How much is that a complete representation also of what we needed to understand what was happening in the past? So systematic science, taking measurements and actually going out and keeping track of what people were doing, what the environment was doing, and all of that. It's a relatively short history. So what about evidence from proxies from the environment? Paleoenvironmental reconstruction type analyses. We can look at palynology, we can look at charcoal layers, we can look at dendrochronology, etc., multiple different possibilities with that. But even that has its limitations. It only records some things. It doesn't record everything. There are things that happen in the environment that don't leave a trace. So we can't know everything doing that either. And then third, what about the broken continuum of experience and knowledge and lifeways between native peoples who lived in North America in the past, still live here, obviously, but with the colonial culture that came in and changed the dominant culture and removed people from their land, remove people from their culture, essentially, there is a break between that understanding of how people conducted themselves and managed with and worked with the environment and interacted with the environment, and then the way the colonial people came and did it differently. And so the understanding of that difference, what's being lost, what has been lost, could be difficult to reconstruct also. So I want to start talking about some research, though, and I want to start with things that have been observed in the recent past. So this is that at the beginning I was talking about the field research in the Sierras that was funded by the Joint Fire Science Program and with an agreement of the U.S. with the U.S. Forest Service. And this has been published it was published in Forest Ecology and Management with ASA as first author and our collaborators with the Forest Service as co-authors. Just to make note of the title, Persistent Composition, Legacy, and Rapid Structural Change, I'll talk about sort of what that means. What's the persistence and what's the rapid change as I talk about the results in a couple minutes. We used 134 permanently marked field plots. We used USDA common stand exam protocols for the original samples that were done. We resampled using those same protocols. And this map over here, so we can see a number of different fires here. In the diagonal is the Chips Fire. The Chips Fire burned in 2012, and it reburned parts of the Rich Fire here, which burned in 2008, and it reburned parts of the Story Fire, which burned in the year 2000. The Chips Fire was somewhere around like 35,000 hectares. Story about 22,000 hectares, and Rich was much smaller, about 2,500 hectares or so. So our 134 permanent plots were spread among different burn categories, reburn categories in terms of, unburned, unchanged, low, moderate, and high severities, and different combinations of those severities. So we wanted to look at, given these reburns and given the reburns that were relatively rapid with a combination of severities, what kind of effect does this have on the species composition, on the forest structure, and maybe we can speculate about what may be happening in the near future. So this is the Chips Fire while it was burning. Of course, that huge plume of smoke there going, who knows how many, 10,000 feet into the air or more. It was quite a large fire. And these are pictures before and after the Chips Fire in a reburn area. So this would have been either in, the chips or rich footprint before, the story or a rich footprint before the chips fire. And then this is the exact same place. You can tell that we've even got, the same coarse woody debris, and standing dead snags are still there. But, it looks like a nuked landscape at this point, basically re-nuked. And this is when we were going out sampling what it looks like. So here's a ton of standing dead snags. Check out this green, layer here at the bottom. This is something that will come up here again when I talk about the results. This is the shrub layer, essentially. So it could be a mixture of oaks, but it's probably a mixture of manzanita, ceanothus genuses. So these shrubs inside the high severity burns come in real thick and basically take over the site. And here we are out here doing a little bit of sampling. I threw this in just to prove that I do get into the field sometimes, but not enough to my liking, that's for sure. So we went out again, we sampled, there was a sample before the chips fire, and then we resampled after the chips fire. And then we, took the data and did generalized linear models. And then after the generalized linear models, did a margins analysis. And margins analysis then allows us to produce a nice little figure like this, where we can look at the effect of the different interactions of the severities on, in this case, we did it in terms of change. So this is change in tree density with these combinations of fires. And the red line on here, this is 0 is no change. So any vertical line, so this is your 95% confidence interval with these vertical lines, any vertical line that's crossing 0 is no significant change. Any vertical line that's not crossing 0, there was some sort of significant change. And where I have, so we got down here on initial severity, we've got unburned, unchanged. The difference between those two is unburned is outside the burn perimeter. Unchanged is it's inside the burn perimeter, but there was no measurable change from Landsat imagery. And that's where we're getting our designation of burn severities. And then low, moderate, and high severity. And then the second fire severities, where they were significant, I indicated them as, and wrote them out basically next to the line that they're associated with. So you can see that, at unburned, unchanged, low severities, and then you burn that with a high severity, you have this enormous negative change in density, which makes a whole lot of sense because a high severity fire is going to have somewhere between 75% and 100% mortality. So, we've got negative changes in density of 620, or so trees per hectare in these areas. Of course, when you get up to moderate and high severity, you have another high severity come through. You've already killed enough trees that high severity is not reducing density anymore. So we also can see that, where we had low severity initially and moderate severity initially, low severity and moderate severity in reburns do cause some kind of reduction in tree density. And that reduction is something more moderate, say 100, 120, 130 trees per hectare reduction. And when you do that, basically what we found is that having these low to moderate reburns reduce the tree density from a mean of 260 trees per hectare approximately to about 162 trees per hectare, which actually then gets that tree density down to what's the natural range of variation. So it gets it within the natural range of variation for the mixed conifer stands in this area of the Sierras. So, it doesn't take that much, it takes just 2 fires, and low to moderate severity, and we get it to a density that really would be reflective of what the past history as we understand it would have been in the natural range of variation in the past, with an actually functioning fire regime. And so it might look something like this. If we can get to a natural range of variation, it's going to be much more open. We're going to have herbaceous species in the understory and have an open canopy or much more open canopy. Of course, this is very open right here, but you can see in here, this is an open forest, much more open forest. And coming back to that shrub layer, and what happens with that shrub layer, we can see that, we've got, again, 0 is across here. In our interactions, we do have positive changes in shrubs with reburns, but those are at relatively low severities, moderate, unburned, and unchanged across low, moderate, and high severity initial fires, create a little bit of an increase in shrubs. What we thought was kind of interesting was if you burn a place at high severity twice in a row in relatively short order, you actually cause a reduction in the shrub layer in terms of its shrub cover. We were speculating that it probably, has something to do with, the tolerance of the shrubs for, this high, rate of reburn that, initially you might have a fire come through and they reproduce, some of them might reproduce from the root stock, and some of them might reproduce from seed, but they really actually are adapted to burn about every 35 years or so, not every 4 or 5 years. So you burn them through at high severity a couple of times, you can actually reduce the severity. The problem is you burn them at high severity, it's probably going to escape into the surrounding forest. You're going to start burning the forest at high severity potentially also. So maybe not such a great suggestion for management. But another thing that we found was that we were able to sample across multiple years, right? So we had about 5 years of sampling from 2009 to 2012, and then up to 2017 and 2018. And what we found was in years where we had above average precipitation, we had really substantial seed germination and establishment. And so we have these years where here's this red line, this is 100% of normal precipitation. And if you get, 120% up to 150, 160%, you get really great reproduction going on in those years. In drought years, we're getting very low, 100, seedlings per hectare, maybe 400. This year is probably a little bit of a hangover from the previous year, getting maybe 600 or 700 trees per hectare, seedlings per hectare. But one thing that's been found out in the Sierras that was being published a lot was people were saying the trees aren't reproducing. And so us being able to find that the trees are reproducing, but they're reproducing only in really good wet years is important to understand. If you're sampling in a drought year, you're sampling in a year where they're not surviving. If you're sampling in a wet year only, you're sampling in a year where they're doing really good. You really have to be able to represent multiple years across drought and flood years to really get good reproduction. My guess is this year in California is going to be a great reproduction year. They're already got a ton of snow out there, flooded themselves like crazy. So there's going to be a good year out there for seedlings. So that's, this is kind of talking about the rapid change, right? So in my title of that paper, Persistent Legacy of Composition, Rapid Structural Change. Of course, the high severity showing rapid structural change here, the, combinations of low to moderate severity fires repeating themselves, pretty rapid structural change. And then, of course, kind of what's going on with the shrubs. The part I'm not showing you, because it's really not that interesting because there's not much going on there, is that the species composition wasn't really changing very much. This system has, in terms of the mixed conifers, you're talking about ponderosa pine, longleaf pine, not longleaf, sorry, that's southeastern US, lodgepole pine, sugar pine, so the true firs like white fir, red fir, and then incense cedar are our dominant species out there. So what you have, we had fire suppression era. We had a lot more kind of less fire tolerant species. The firs start doing really well. The incense cedar's doing really well. Well, even after these repeated fires, we see that in terms of the canopy dominance, you still see a lot of those firs and incense cedars in the dominance in the canopy. But you also see with the seedling reproduction, that those species are reproducing really well too. So you're not seeing this really rapid shift going on where, like, say, ponderosa pine and sugar pine are becoming more dominant because they're more fire tolerant. The white firs and the red firs and the incense cedars have gotten big enough and their bark has gotten thick enough that they can survive low to moderate fires, and they produce seeds like crazy. And so you really, the future is not like, oh, we're going to see a huge shift here in species composition. So that's kind of your persistent legacy part of it, along with the rapid structural change. So looking at the next paper, this is, it says in review, we got comments back with major revisions that we need to work our way through. It's a process. But what we wanted to do then is we have that on the ground plot level analysis. We wanted to get a little bit broader and start looking a little bit at the landscape also, and a landscape level type analysis. So we wanted to look at, okay, what's the effects of these fires then on landscape heterogeneity, on aggregation of and dominance of shrubs and conifers versus each other and those types of things, and change through time, how that's changing through time. And so this is the study area. It includes the fires I was talking about previously, so the chips and the rich and the story fires. It also includes a few other ones like the Bucks Fire and the BTU Lightning Complex and the Bar Fire, and then Cub Complex and Smoky Fire. And we picked a little bit larger area. We wanted to get some more fires involved, and we wanted to get some areas that hadn't burned also, so that we could take a broader look at the landscape. So we took two different time periods. One is, remember I said story fire, which was like our earliest fire, was from the year 2000. So we're like, okay, 1999, we can get some spatial data on vegetation type from 1999. And ASA took that data and then used aerial photography, because it was produced from Landsat satellite imagery, which, the resolution's okay, but if you have aerial imagery, much better resolution. She could QA/QC this data and really get it, really accurate, and make sure we had the right pixels, the right vegetation type. So we basically gave, everything in green is conifer, red is shrub, and then we have kind of like, some others in there, and hardwoods. And then basically same thing with 2014. So this is after all of those fires that was on that map there, those 8 fires. You can see how it's changed a lot here within the boundaries of the fires. You can see the fire boundaries are in here in blue, and then all this red is all the shrub patches that have been added. Some of these shrub patches are enormous. You can see here my scale. So from 0 to say, 10 kilometers here, some of these patches are that long, like a 10-kilometer long scrub patch that used to be conifer, right? So a major change in vegetation type. So then what we did is we used FragStats. If you haven't heard of FragStats is a package that does analysis of raster data to look at patterns within your raster data, patch level, landscape level patterns across the landscape. And so this bar graph here is the percent of the landscape that falls within each class that we defined, right? So we defined a high severity burn patch with conifers or shrubs in it, low to moderate severity, and then just burned areas, unburned areas, and then the full landscape. What's really important, I guess, and interesting here is kind of these first 3 areas. You can see that high severity, of course, again, you're going to have all this mortality of conifers goes from, over 80% of the landscape down to 10%, and shrub goes from a couple percent up to close to 90% within the high severity area. So you can see how there's this flip between conifers and shrubs. And then low to moderate severity, it's not as drastic as a flip, but you do see, you get this evened out landscape now within these patches where conifers are down to less than 50% and shrubs are about 50%. So you can see that it's not dominated really by one or the other. And then in burned, just in general, it's a similar sort of thing, but you have more conifers and less shrubs. If we look at aggregation index, so this is measuring how much of our patches of conifers and shrubs actually aggregating, and how connected are they big patches, or are they a bunch of tiny little patches all over the place? And again, same sort of breakdown. In high severity, you see, conifers go from being relatively highly aggregated to much less aggregated, and shrubs really aggregate themselves a lot. Whereas low to moderate severity is not as much of an effect there. And then in terms of diversity, we have Shannon Diversity Index, Shannon Evenness, and Simpson's Index. And in high severity, you see that diversity declines after high severity fire. Low to moderate severity, it increases a lot. And in burned areas, you see an increase of diversity across the landscape. So low to moderate severity, and in burned areas, you really see kind of the increase in diversity and sort of the effect you might want to have in your management if you can get those types of fires. The third one is looking to the future. So we wanted to take that same study that I just showed you, looking at just recently observed past from 1999 to 2014, and go out 100 years to 2114. And we wanted to say, okay, with climate change, what's going to happen to the amount of landscape that's in shrub? What's going to happen to the amount of landscape in conifers? What's going to happen to diversity in this landscape? So this is in preparation, hasn't been published. We hope to submit it soon. And this is our simulation area. We have 157 fires across this area, and between 84 and 2019. And then we're going to try and increase the fire frequency based on this publication from 2022 that says this is a global average, but the maximum increase in fire frequency is going to be a 1.57-fold increase by 2100. I'm gonna have to go through this pretty quick because I need to get to the last part I want to talk about here. Basically, we increased fire probabilities over into scenario 3, increasing it by 1.7 times, because actually we were going past 2100 that paper had. We're going 14 years past that. So we did 1.7 times. So we did 3 scenarios. We did a 1984 to 2019 scenario, and then a more narrow scenario for the last previous 10 years, which has a bunch of really large fires and no years with 0 fires, and some years with even up to 18 fires across the simulation area. And basically how this worked is we had the model use the probabilities of fire, the fire probabilities, the number of fires each year, using the probability of the number of fires, takes that, based on probability, how many fires you're going to have in a year. And then it takes that number and it puts randomly fire locations. Say it was going to be 18 fires that year. It's going to put 18 fire locations across the simulation area. And then it's going to select those fire events from the historical data, the spatial data, and it's going to put them in those 18 locations. So randomly selecting from the 157 fire events, put them in the landscape. It repeats it 100 times for 100 years. We do it 100 times for each scenario, and then we do the frag stats analysis. And then we also want to understand how vegetation is going to change. So, did we have high severity fire? No. Then we have no change in vegetation type. If we did, was it more than 20 years old? If it wasn't, then we just convert the entire thing to shrub. Now, the 20-year thing comes in and is important because we're assuming that we'll have dispersal of seeds into the high severity patches, and we can start to get trees coming up above the shrub layer and becoming dominant. And that could take about 20 years. And if so, then we infill the polygon at a rate of 33 meters from the edge of the high severity patch inwards to fill it in with conifers. So we do have an infill rate with conifers even in the high severity patches. So what does this look like? So this is for reference, this is 2014. This is observed data. This is scenario 1, which you see there's not a whole lot of big shrub patches on here. This was using fire data from 1984 to 2019. So you have a lot less burning going on. And then this is scenario 2, which had the more recent fire regime in the observed history. And you see it looks more like, maybe more like this, but not quite. And then this is the climate change scenario where we increased fire fire frequencies with 1 by 1.7 times. So looking at this from FragStat's point of view, you can see this is scenario 1, 2, and 3. The scenario 3 average of conifers percent of the landscape goes down to like 75%. The percent of shrub goes up to say 20%, 20% or so. Historically, in 2014, the percent of shrub in the landscape was 17%. So really, actually, this future scenario is not that much different from what we observed in our study area in 2014. I'll explain why that is in a minute. And if we look at diversity, we can see diversity is increasing with our different scenarios, scenario 3 having the most diversity. And in 2014, the Shannon Diversity Index was 0.75. Well, you can see that in scenario 3, it's like 0.76, 0.77. It's not that different from the observed area. The reason is that area that we analyzed in 2017, that area has had a bunch of human set fires, accidentally human set fires. There's a railroad track that goes through there. They were doing construction on the railroad track. That's what caused the CHIPS fire. PG&E, which is the electric company out there, has a bunch of infrastructure going through that region. They failed in maintaining their infrastructure. It set fires out there. That's where a bunch of the other fires came from. So this study area that we decided from 2014 to do our analysis has like this much bigger much higher fire frequency than the rest of our simulation area did. So really kind of what we did with our simulation area is we showed that we can, create this model that can kind of give us an average across our simulation area, but your simulation area is going to have high fire severity, high fire frequency areas, low fire frequency areas. And some places like our study area from 2014 is going to be a place that just burned a lot. And it already looks like we think the whole area is going to maybe look like on average 100 years from now, our study area in 2014 already looked like that. It already looks like climate change in 100 years. So it's really kind of an outlier sort of area across our study area. So let's talk about then the past and what can't be observed in the past. And that those of you that were reading the paper for this class, that's what this is about. This was published in 2022 in the Canadian Journal of Forest Research with ASA again. And the first thing I want to talk about is what I made up this term, I think. I don't know, maybe I didn't. Do you guys know what the Great Unconformity is? Anybody know what that is? You've been to the Grand Canyon?
Yeah.
Right, you guys been to the Grand Canyon? The Great Unconformity, it's a geological term. And it refers to the Grand Canyon because the Grand Canyon, the rock, the metamorphic rock at the basement of the Grand Canyon is like 1.7 billion years old. The sedimentary rock that sits on top of it, the oldest sedimentary rock that sits on top of it, you see all those horizontal layers? Sitting right on top of that, the schist, the Vishnu schist, is about 600 million to 700 million. That break between the metamorphic and the sandstone is called the Great Unconformity. You lose about 1.2 billion years of geologic time in that break, right? The Great Cultural Unconformity is the millennia, I'm calling the millennia of native peoples living in North America, and then they're gone, essentially, in terms of their effect on the landscape. And then colonial culture moving in, and the loss of the culture, the loss of the knowledge, the loss of the lifeways on the landscape. Some people might not like me using that term, equating geology with people. I'm sorry if that's offensive, and I do apologize. but it's just, I'm using it as a way to get at that concept, is equating the two. And then there's the principle of the drunkard search. I wanted to use that also. Anybody know what the principle of the drunkard search is? Ever heard of that before? You probably have, and you may not know the term. But the story is, or the joke is that a cop is walking the beat and he sees this guy here underneath the street lamp on his hands and knees looking around. And he's like, what's going on, dude? And he's like, I lost my keys. And he says, where are they? And the guy says, I don't know. I lost them somewhere over there, but I'm looking over here because that's where the light is. And that, in essence, is sort of what we're doing a lot of the time. We are looking for answers in places where the light is shining, where we have information already. And we can only really look in that place, right? We feel like we can only look in that place because maybe we might feel like we might be making something up if we don't, or we might not know a way to think around that problem to get to some potential answers that may be in the dark, right? They're not visible to us. Again, for us, the past is behind us, behind our head. It's not visible to us, right? So the pre-Columbian native peoples living in the Sierras, they, reduced fires. They set fires to reduce fires and reduce dangerous fires, to promote useful species and to promote hunting, grazing for species they might hunt. So they, influenced composition, density, fuel loads, and fire regimes by doing so. But they also influenced forest structure and fire regimes by collecting biomass. And that's something that is that's sort of the lost sort of thing here, because it doesn't, that's what I was talking about at the beginning, things from the past we don't know. There are some things that don't leave a trace. Now, burning firewood in a fireplace, in a hearth, it's going to leave some charcoal there, obviously. But can we reconstruct the amount of wood that was burned in that place just by the remnant charcoal in that hearth? Probably would be pretty difficult, right? But they did collect firewood. They did burn a lot of firewood. They were doing it all the time, every day, for cooking, and then when it's cold, for keeping yourself warm, right? They also used wood for building homes. This is a wickiup. Built out of sapling poles and then the bark of incense cedar. And then look at this basket. That's beautiful, right? What this amazing handiwork. So they were using biomass all the time. And here are pictures. There are not a lot of pictures of native peoples from North America collecting firewood, but I just want to point this out that, look at the wood bundles they're carrying. And then look at this woman here. She's got this nice basket on her back, which would be a good burden basket also, right? So let's take a look at some people from around the world, because we don't have good numbers on what's the volume and mass of wood that was being used to cook and to heat before colonial peoples came. So we have to take a look around the world. There's people around the world where there is systematic science going on, where the biomass is being measured by people on the ground. And check out what they're doing. They've got wood bundles that they're carrying on their backs. They've got baskets, burden baskets carrying wood. And these are in the Himalayas in India. And these people are from Mexico, the Tarahumara people. They are culturally connected to people from the southwestern United States, from southeastern Arizona, southern Mexico, southwestern Texas, share the same history, cultural, language background as the Tarahumara. These are modern pictures collecting firewood for heating and cooking. So what's the problem then that we're trying to answer? Okay, well, we've got these disturbance synergisms in the Sierras, fire suppression, changed, the structure. We have this development in the wildland-urban interface, and then we've got climate change, right? We have more, larger, high-severity fire. Here's ASA in the field collecting data in a high-severity fire area. I think they had created like a barbershop quartet here. It looks like Asa is singing or something in this picture. And then, of course, life of law, property, money. And so what's the answer? Well, a lot of people, the Forest Service is saying, scientists are saying, more prescribed fire. Makes perfect sense, right? We've been doing it for a while. It works. I'm not going to stand up here and tell you it doesn't. I am going to say this, though. We've had, in the past 2 years, 2 fire moratoriums. This year, really obvious one that became very published because of the fires that occurred down in New Mexico. Then the chief of the Forest Service said, for the next 6 months, we're not going to do any prescribed burning. And the year before that, the chief of the fire service said, we're not going to use natural fires anymore and let them burn. We're going to fight everything. So this has been going on for the last 2 years. Imagine what's going to be happening with climate change as things get hotter and drier in a lot of places. Is this answer with prescribed fire going to end? Is that the only answer that we have? You know, of course, thinning got that too. So we wanted to use modern proxy biomass collection estimates and try to examine, we can't do it perfectly. It's really a thought experiment. How much fuel load were they impacting? How much fuels were they impacting by collecting biomass for firewood? And so the rationale is that we've kind of lost these practices on the landscape, but the concept could be beneficial for management. And in other parts of the world, like in India and Nepal, there is research that shows that firewood collection on a large scale, people who are dependent on it for all of their energy needs, do have an effect on fire regimes and fire damage. So I have to speed up a little bit. I'm going to cut out the methods for the most part, I think is what I'm going to do. But again, we're in the Sierras, so I'm concentrating on analysis of across the Sierras. We did use published data. This is our estimates of population size, pre-Columbian population size. And this is our size that we're using for the vegetated part of the Sierras. And then we collected published data from a few different sources. So in Garhwal, India, which is up here in the Himalaya region, sorry, I want to say it correctly. It is Himalaya, I've been corrected for saying it wrong. So there was, at 2 different elevations, we have 1.73 and 1.02 megagrams per capita per year of biomass collected. And then in Almora and Chamoli, 0.6 and at 1,500 to 1,600 meters and 0.18 at a higher elevation in Ramara village and Farika village. Similar region here, same in Uttarakhand state. And then of course in Mexico, in this region, this is where the Tarahumara live, and they moved there to escape the Spaniards and the Mexicans. And so that's at a higher elevation, and it's 1.72 megagrams per capita biomass. So in terms of fuel loads, the modern fuel loads in the Sierras are not okay. They don't reflect anything that was equivalent to what it was like in the pre-Columbian era. There's just too much fuels all over the place all the time. And it's in some places rather scary. There's multiple times I've been in the forest in the Sierras and walking around and I just want to get out of there because it's just there's so much fuel. It is really scary in some places. But we tried to get fuel estimates from the San Pedro San Martir, which is managed with kind of a historical fire regime. And what is the fuel accumulation rate there of 0.03 megagrams per hectare per year? And that's in the 100-hour fuels. I only used 100-hour fuels. 100-hour fuels are 2.54 to 7.62 centimeters in diameter. One reason I use that is because you saw those pictures. Those are the sizes it looked like those people were carrying. They could use larger sizes. These are all our calculations. I'm going to go past those just to get to the results though. Okay. So this is catchment size, right? And this is in hectares. How much area would a single person need to use to get enough fuel to fulfill their needs for a year, right? So that's catchment size this is per household, actually. And so, 154 hectares all the way up to 400 hectares this is from the estimate from Mexico. For a full settlement, anywhere from 770 up to 2,000 hectares for a settlement of 35 people. And then for the entire population of the Sierras, from 90,000 people up to 100,000 people, somewhere between 60,000 megagrams per year, all the way up to 171,000 megagrams per year. But what does that come out to in terms of the size? How does that compare to the Sierras as a total in terms of its vegetated area? And the black line is the entire Sierra's vegetated area, about 34,000 square kilometers. But if you were using the estimates of per capita biomass from Mexico that we used, you'd have to use, it'd be this line up here, 5,000 to like 5,500 square kilometers. So at that point, you're getting close to, 1.5 to 2 times the size of the Sierras. The other ones are either equivalent to the entire size or below it. But if you're getting at the size of the Sierras to above the size of the Sierras, obviously you have to change sources of biomass. You can't just use 100-hour fuels. You have to use larger fuels. You'd have to cut down, smaller trees maybe. You'd have to prune trees. And that's what they also were doing. They were pruning limbs off of trees. They were raising the base height, right? So they were raising the base height so that any fire that's burning through might not catch the tree and get into the canopy. They were thinning the understory also. They were also removing fuels from the surface, right? And so by having these estimates of just 100-hour fuels, we can get an idea they would have to switch fuel sources and have impacts on other fuels too. So this is the last slide. There's a great amount, of course, that's unobservable and uncertain about both the past and the future, as you can see, right? We can use models. We can kind of recreate what we think was going on in the past, use some modern proxies. We use modern proxies that are in trees, in sediment layers. We can use modern proxies even from people too, like we did. But, the one thing obviously we can be certain of, even though we have all this uncertainty, is that change, is going to happen. Change is a thing, and forests are going to change globally. So the bigger question maybe is not, is there going to be change, but are we going to be adaptable enough to be able to meet that challenge of change? Native peoples, they lived in the original wildland-urban interface. They were in the forest. The people that live in the forest, they were there in it, right? All the time, living in wooden houses they didn't have, firefighters, I guess, they didn't have fire trucks, that's for sure. You're in it, it's burning around you. You got to be managing your system, right? They were adaptive. When places got too dry, they left them. They were out there constantly also having interactions with their environment. So they had this sort of constant, what we call it, the socio-environmental, interactions and systems. They had, their whole lives were centered around that, right? So maybe surface fuel harvesting might have a role to play in future adaptive management strategies. Especially, as the climate warms, as prescribed fire becomes maybe more difficult. It also could result in some new markets potentially. If instead of going out and doing piling and burning, what if we did harvesting and just removed it instead of burned it? And then took it somewhere and we used it as biofuels, or we turned it into biochar, created soil amendments out of it. You can then sequester that carbon instead of just releasing it to the air. And then also have a positive effect on fire regimes and reduce dangerous fire regimes in the forest. So then you're capturing more carbon in the forest also. So as sort of my whole talk is kind of leading to, and the, you know, the drunkard search sort of indicates also, you know, the insights and answers, they'll come by shining the light in all the dark places, right? And creative and novel approaches using what we can see to understand what's out of view. So shining that light in those dark places, try and use what we can know, and maybe we can help understand what we don't know, what's out of view, what's behind us, as the Aymara people would say, what's our future behind us. And that's it. These are my references. Thank you all. That's awesome. And so I came here from Florida, right? This picture was taken off the coast of Florida on a cruise ship between the Florida and the Bahamas. It was a nice, beautiful day that day with a nice, beautiful sunset. And when I go back there, it'll be 80 degrees again, as it was when I left. So I guess we have time for, I didn't leave as much time as I was supposed to, but we do have a few minutes for questions if anybody has any questions. Yes.
Yeah, thanks for your talk. I'm curious if you collaborated at all with the indigenous people from the Sierra Nevada in your project.
No, actually. That's something that, so we're trying to, and one of the reasons Anne is here and Sri is here, and I've been talking to them and working with them to try and produce some proposals that so we can get some funding to maybe also work with, not in the Sierras, but work more in this region actually, and into, you know, southwestern Colorado, into northern Arizona and northern New Mexico. And so Tony Chang, who he, you know, when I spoke to him, gave me the insight that there's a group that he is involved with, that he has connections with, that are involved with biomass harvesting for firewood. And it's a, you know, kind of an organized group. And I think it would be really good if we can kind of connect in with that group to be able to work with them and see what they're doing and what kind of effects it's having, and you know, in their interest. But no, to this point, no, have not been able to work with them yet. And by the way, I want to say, because this idea of this last talk, the last part of the talk, and that paper, it came from basically from Asa and one of my other PhD students, Rabindra, both of them from Nepal. And through my conversations with them, and this is one of the, okay, so this is one of the things that I think is a kind of a broader thing to think about. We hear a lot about diversity, and we hear about inclusion and diversity, and we hear a lot about, I'm in the middle of conducting a job search. We had to have people send us diversity statements. You will probably maybe have to do one of those if you look for a job in academia or something. It seems abstract in a lot of ways, in some ways, you know, and it depends on where you work, where you go to school, the people you're surrounded with. It can seem abstract. But I will tell you, by having these two international students come and work with me in my lab, it led directly to that research, because they told me about their home. They told me about, okay, our people, you know, back in Nepal, it's regular every year in our villages. Every year people go out, they're going out into the forest. You saw pictures from India and people going out every day even and collecting wood. But in some places, then they also, on top of that, every year they kind of have, the whole village kind of goes out and does like this regular management and maintenance of downed biomass and standing biomass in the forest as a regular management. And they tell me it's stopping. People are stopping to do it because people are moving to the cities and people are moving out of the villages and stuff like that. And like, you know, so in some places, fire regimes are changing because the people are leaving the land and they're not conducting the same things they used to, right? And so that paper came out of those conversations, and thinking, well, geez, there were people here and have been people here doing that exact same thing. We basically removed them from the land for the most part on purpose. And it wasn't that they chose to go to the cities, but obviously that would have had an effect. There would have been this huge effect of people collecting biomass, and then they're not. And so then that whole process of management is not happening anymore. And then, we go in and we decide, well, we're going to suppress all fires because, we've had a few bad ones and we want to protect the timber. And then we come back later on and say, well, we want to start doing prescribed burning again. But now you're doing prescribed burning in a situation where you're not also doing as much of the fuels management by hand. You're doing some of it, you're doing some pile burning and stuff like that, but you don't have the people on the land all the time out there every day, pulling the biomass off the land. And so it's a different situation. We're going back and trying to manage in a way that the native peoples were doing, but not the whole thing, not the whole suite of management applications, just one part of it, right? The part we can reconstruct from dendrochronology and the part that we can reconstruct from charcoal analysis, but not the part that can't be reconstructed per se, because there's not evidence of it. Because you're burning wood in a hearth and it's gone, right? Anyway, any other questions? We're at 5:02 though, so.
I got a question.
Yeah.
So back to some of the earlier data you presented.
Yeah.
On the shrub, the lack of kind of regrowth or the decrease in abundance or cover after the 2 high severity fires.
Yeah.
And so you kind of mentioned the reproduction from seed versus resprouting. So
Yeah.
do you think like those repeated burns are like decreasing seed bank and they're not able to replenish seed bank, or is it that they're not able to resprout after 2 recent fires, or some combination of both?
There might be a combination of both, and I think the literature suggests that there could be a couple different processes going on. The part with the seed, I think, would be that there is a seed bank, right? And there is seed there, and they produce a lot of seeds. But that, you have that initial high severity fire and things start growing from seed, and you are exhausting some of that seed bank that way. And also by high severity fire, you may be killing a certain amount of seed too, by just roasting it, right? So by doing that a couple times, that could be reducing the seed bank. And then if you're burning too soon, they're not reaching maturity to produce enough more seed. So then you're not replenishing the seed bank, right? Then of course, there's the question of the resprouting capability. And there's some evidence that from that other people have done that, yeah, they do potentially lose some of that capacity for resprouting with repeated high severity fire with some of these species. Some of them seem to do okay and some of them don't do okay. So, but we didn't, like, in terms of the shrubs, dive down into the species differentiation. We just went, it's shrub and it's cover, and that's okay with us. Any other questions? Yeah.
What other opportunities do you think there are for like indigenous-led practices in our climate adaptation?
That's a good question.
Can you repeat it?
Sure. Yeah, he said, what other opportunities are there for native peoples to lead, sort of adaptation in as we face climate change? And that is, that's a great question. One thing I mentioned in my talk, which is obviously not going to be it's a non-starter, is that there is obvious evidence on the landscape that native peoples abandon places with climate change. In the Sierras, for instance, in periods of time, so their settlements would have been in the valleys, right? And so they would have gone up to close to tree line and had some permanent settlements close to snow line. And then only use the higher elevations during the summer, right? But in colder periods, and if you have like say the little ice age or something like that, there's evidence that they would abandon the valleys, move farther down valley, because the snow line would move down with those colder periods. And obviously in other places, there's periods where, right now, they talk about the droughts in California being the biggest in the last millennium or something like that. But there's been native peoples that were here for many millennia, and there's evidence that they abandoned due to drought in some places. Now, we obviously are in a situation in the southeastern US. You guys are connected to that because of the Colorado River, even though you're not getting your water maybe directly from the river here. The people downstream in the desert Southwest, California and Arizona, are getting a lot of water from the Colorado River, and those big reservoirs are drying up. Now California got a lot of water this year, so that helps for them a lot. But who's talking about abandonment of Phoenix? Nobody, right? Obviously, I don't know if you read, Phoenix just abandoned, it wasn't Phoenix, it was Scottsdale just abandoned their neighbors to like the north of them or something like that, because they were sharing water with them. And then they cut them off and said, we're not sharing water with you anymore, get your own. There's none for them to have. And there's like 1,000, residents or houses or something like that were just cut off. What are those people gonna do? The smart thing to do would be to take off. But you've just dumped all your money into that property. What are you gonna, are you gonna give up on that? I don't think so. I live in a hurricane zone and I fear hurricanes. At times I think I should just abandon my house, because it's going to get destroyed at some point. But hopefully, the next person is dumber than I am and will buy my house at an inflated price. But I mean, yeah, other than that, there's probably things out there that I'm not being an expert in everything, Native American culture, I can't speak to. But I think it's a great question. I think and that's sort of the point. I mean, the point of that paper, it has a very specific point about fuel management, but also part of the point of this presentation is to think about that bigger question. What are the other things? What are the other things that we don't know? What are the things that maybe have been lost? And maybe some things that are lost, we just can't recreate that knowledge. But are there things that we can recreate that we know obviously were happening, but we don't really understand? And that's the thing with the firewood collection. And that's why it was an aha moment for me to speak with my Nepalese students, is that they experienced it on the ground and told me about it. I have no experience with that myself. And 99.9% of people in this country have no experience with that themselves. Now, you may come from a place where you might have a wood burning stove and your family may buy a few cords of wood or cut down some trees and chop up some wood. But that's a little bit, you don't depend on that energy source for all of your energy. The people that I'm talking about in Nepal, those people nearly 100% or 100% are depending on biomass. The Native Americans were depending 100% on biomass for their energy source. So it's very different in the amount that they're doing it. It's very different in the dependence. And even if, like I said, you're using cordwood for a wood burning stove, you still have electricity. You still might have even gas at your house. Your dependence on it is different. And then the way that you're getting it is different too. You're cutting down potentially a whole tree, whereas they're collecting fuels on the ground. They're, getting dead limbs and just thinning small trees and not cutting down a big tree. So sort of a different scenario. So again, there may be things that we know about, but that we don't think about because our current modern culture has no concept of it really in terms of its practice and what it means, because we don't experience it. Any other questions? We maybe past our time, but.
Let's thank Scott one more time for coming here.
Thank you. Thanks for having me. I love Colorado. Ask me back again. To stay longer next time.
Yeah.